All right, so this is your lesson 3 homework. And this is where we get those explicit instructions on how to use a table to determine if something is proportional. All right, so a type of quantity, so one thing, right, is proportional to a second quantity, right, if there's a constant number such that the product of each measure of the first type and the constant is equal to the corresponding measure of the second type. Yo, that's a lot of mathematical jargon to say, hey, two things are proportional if there's a constant that both numbers can be multiplied and their rate increase equally. All right? So the way to determine this is what I want you to focus on, and we'll practice putting this math language in our head, being able to recognize it, and then communicating back out in our own words. All right? So this says for each row or column, calculate B over A, or B divided by A, where A is the measure of the first quantity and B is the measure of the second. All right? If the value of B over A is the same for all numbers for each pair, then the quantity is proportional. This B over A, it's going to be the unit rate, okay, more times than not. But it's also going to be an equivalent ratio to whatever we create. To whatever two sets are in that table or chart. All right, then we drop down, and it says in each table, determine if Y is proportional to X, explain why or why not. So we're going to be using B over A or Y over X. All right. So we should be able to come up with that by seeing if our tables increase or decrease at a constant rate. Let's check it. 12 over 3, right? 20 over 5, 8 over 2, and 32 over 8. All right, so working down, I got equivalent ratio, 4 over 1. 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 All right, so all of these are proportional. So in this case, I would say yes, comma, Y and X can be multiplied by 4 and 1. All right, let's looking at the second one. Let's look at the second one, create some equivalent ratio. 15 over 3, 17 over 4, 19 over 5, 21 over 6. Now the first one is going to be 5 to 1. Now looking at 17 over 4, I know that 17 is not divisible by 4. I know that's going to give me a decimal. I know I have a whole number of 5. I do not have to keep going. This is not proportional. All right, looking at this scenario, I have 4 over 6, 6 over 9, 8 over 12, 2 over 3. All right, so here we got 2 over 3, 2 over 3, 2 over 3, and this one is 2 over 3. Yes, it's proportional. All right. Now looking at my homework, I'm going to see if one of y'all call me on it. All right. Kayla made observations about the selling price of a new brand of coffee that is sold in 3 different size bags. So they're selling this new coffee. People like me want it. People like you don't need it. You're too young. Don't drink coffee yet. All right. Drink some good water. Drink a smoothie or something. All right. Kayla made observations about the selling price of a new brand of coffee that's sold in 3 different size bags. She recorded those observations in the following table. Kayla is a powerful consumer. All right, she's walking around with tables and charts comparing prices of coffee in the store. She's a knowledgeable consumer. All right, ounces of coffee, 6 ounces, price in dollars, $2.10. Ounce in coffee, 8 ounces, price in dollars, $2.80. Then we have 16 ounces of coffee for $5.60. What we want to know is the price proportional to the amount of coffee? All right. So in this case, I want to know if price is proportional to coffee, right? So I want to know if my dollars per ounce are proportional. All right? Now that's key. You have to look at the language in the problem. That's what told me to find out dollars per ounce. All right, so I would need to set up a division problem. I would need to find out the price per ounce. All right, so on the first one, $2.10. What is that going to cost me per ounce? It's looking like 35 cents per ounce. Let's check and see if that rate holds true. $2.80 for 8 ounces. 35 cents also. $5.60 for 16 ounces. Before I give you that one, look at the pattern right there. 8 doubles, the price doubles. So these are definitely proportional to each other. This is proportional to this one. So 16 ounces at $5.60 is proportional to 6 ounces for $2.10, because in all of them I'm paying 35 cents per ounce. So yes, it's proportional. Because each ounce costs 35 cents. All right. Use the relationship to predict the cost of a 20-ounce bag. Man, look, to figure out the cost of this bag, this is where you go back and you use that proportional equation. That Y equals K times X. Y and X are the two units that we're comparing, all right? K is the constant of proportionality. In this case, K equals 0.35. All right, or 35 cents, all right? In this case, we set up dollars over ounce. If we refer back to our B over A equation, Y over X, Y is the one on top, okay? So that must be dollars. So X must be the ounces. I would need to do Y equals 20 or 0.35, 35 hundredths times the 20 ounces. Now, of course, you should be able to do that math, but we're just going to use our calculator for the sake of speed. I'll find out that that bag should cost me $7, right? Now, if I want to check my work, what I should do is set up that equation and do 7 divided by 20, and I should come up with 35 cents, which I do. I checked my work. I responded to all my questions. Now I'm looking at the next number. All right, you and your friends, y'all going to the movies. Fun. The cost of admission is $9.50 per person. Create a table showing the relationship between the number of people going to the movies and the total cost of admission, and then explain why the cost is proportional. All right? So bam, I need to make a table. I know I'm going to have 2 rows or 2 columns. Right? And I'm going to have several layers. It doesn't say how many friends. I don't have a lot of friends. I'm going to jump out there with 3. All right? I'm going to put my cost. Number of people. Let's say 0 people go. It's going to cost me $0. Let's say I'm going solo. $9.50. Let's say one of my friends goes. Well, the cost is going to increase by $9.50. The number of people is going to increase by 1. So I know I'm at $19. Let's say a third friend goes. The number of people is going to increase by 1. So I'm up to 3. Cost is going to increase by $9.50. So I'm going to do 9 plus 19 plus 19 plus $9.50. Let's see. 19 plus 1 is 20. All right, I got $8.50 less. 20 plus $8.50 is $28.50. I'm up to $28.50. Look, I can see that this chart is proportional simply because for every ticket I add, I'm going to add the same cost of $9.50. You should be able to determine that and write that down for us. All right. For every page his Gil can read, his daughter can read 3 pages. What? Oh, I read that wrong. For every 5 pages Gil can read, his daughter can read 3 pages. All right? Let G represent the number of pages Gil reads, and let D represent the number of pages his daughter reads. You see how they did that? Gil got a G, and his daughter got a D. Gil got a G and his daughter got a D. Create a table that's showing the relationship between the number of pages Gil reads and the number of pages his daughter reads. Are the number of pages proportional? Look, if you haven't figured it out by now, all of these relationships have been proportional because it's telling us the rate. But let's go ahead and make it. We got G, which is the number of pages Gil reads. We got D, the number of pages his daughter reads. Gil reads 5, daughter reads 3. Well, Gil's going to read some more. He's going to read. He's up to 10. It increased by 5. Hers increased by 3. She's up to 6. We can go to 15 pages his dad has read. His daughter's up to 9. You can see the pattern there. It's increasing at a constant rate. Do your homework.